In this section, we're going to do combustion and decomposition. So combustion is pretty simple. It is when you add oxygen to something. That is a requirement. It's non-negotiable. It is, when we talk about combustion, a lot of people think of fire, right? It's burning of fossil fuels or hydrocarbons. That's what your cars do. That's why the engine in most cars, unless it's an electric car nowadays, is called a combustion engine, because it burns fuel to make a fire, to make the pistons move and, make the car go. So that's the general idea. Your products are carbon dioxide and water. That's always going to be, well, not always true, believe it or not, but that is almost always true. So let's just make this more accurate. I guess often is a better word. Light and heat are a product, although we don't always see it. And another name for combustion is oxidation. So it could be called either one. So combustion for organic compounds is simple. You take any organic compound, so this is typically a hydrocarbon, okay? So this is your hydrocarbon right here. Don't worry about the two in front, that's balancing. So again, we're not too worried about that. But it's C8H18. You add oxygen. Again, I'm not worried about the 25 in front, that's a balancing issue. So you take a hydrocarbon, you add oxygen, and look what you get. CO2, H2O, and energy. So that's organic combustion. This part, the actual hydrocarbon, it could be anything. It could be C8H16, it could be C2H4, C2H6, C2H8, if that exists, it doesn't make a difference. Some hydrocarbons, so carbon-hydrogen combination, that's what a hydrocarbon is, add oxygen, you get CO2, H2O, and energy. The energy part doesn't even really need to be there because it's so common that a lot of people just assume this part and they don't even write it in sometimes. All right, so that is organic combustion. So if you look, here's another one. This is a hydrocarbon. You get oxygen. You add oxygen, you make CO2 and H2O. I didn't include the energy here. It doesn't have to be there to be combustion. Here's a different organic combustion one, C3H8, but if you notice, this part's the same. Oxygen, you add oxygen, you get H2O and CO2. These two are inorganic combustion. So these still count as combustion, although a lot of times scientists would be more likely to call this oxidation, although oxidation and combustion, you can really lump them together. So if you notice here, I'm adding oxygen, but there is no CO2 and H2O byproduct. Instead, I'm actually combining the S and the O. Here I'm combining the Mg and the O. So this does count as combustion, although most people would call it oxidation. Most scientists would call this oxidation, even though combustion is a synonym. All right, and these also count as combination, addition, or synthesis. And the reason is because we're adding two elements together to make one, adding two together to make one. So it turns out some chemical reactions do fall into more than one category. The last one that we're going to do on this page is decomposition. Decomposition, just like biology, decomposers, they break things down. So a decomposition reaction is going to be a reaction that breaks down a compound into its individual elements. So here, MgNO3 twice gets broken down into individual Mg, individual N, even though there's two, it's still an element, so it counts, and individual O. Even though there's a two there, it still counts. These two are part of Brinkelhoff. Hg and O gets separated into Hg and O individually. The effect, again, the O2 doesn't matter. H2O can be separated into elemental hydrogen is a better way of saying it, and elemental oxygen. That's their element forms. So that's decomposition, and that's everything on this page.